I am, thank you. X raised to the 4th plus 5x to the 3rd. 3x squared minus 4x. Okay, I like this graph, but I can't see all of it. Look down here. There's part of it missing, so I need to go lower. How do I make my window go lower so I can see everything? Window, and then what do I do?
Y. I think it's Y mid.
That is correct. So what we do, guys, and everybody, let's do this together. Hit the window, and let's arrow down to Y min, and we want to make it go down further. Do you think negative 15 will do it? Negative 20? What you want to try? Negative 15. Okay, we'll try that, and then we'll go look. I hope yours is faster than mine. Oh, it's so close. We can really see it's really right on the edge there. I may just do negative 18.
I did negative 20.
You did negative 20? All right, I'll do negative 20. Okay, now we can see everything about the graph that we need. So I'm going to snip it and go put it on our page. And you can't snip it, but you can sketch it. Okay, so guys, I'd like you to sketch the graph. Okay, so sketch a little picture. All right, we're going to talk about vocabulary again today. What is the difference between absolute and that local or relative? Okay, this one has both. Okay, who is about to tell me absolute? Yes, ma'am.
Absolute is when there's nothing below.
Correct. Okay, so we do have an absolute. All right, Taryn said it's when there's nothing below that point. She's right. That's an absolute min. It is absolutely the lowest y value on the whole graph. So let's go find that one first. Okay, so we're going to see if we can go locate on our graph that point right there, because this point is an absolute min. Okay, so let's go back to our calculator, and the way we find a minimum is this. I'm going to clear this. Okay, it's already clear. You hit, no it's not, second and trace. Second and trace. And then this time we want the minimum, so it's choice 3. Now this is where our calculator prompts us. Look right over here. It says left bound. Well, my cursor is right here on the y-axis. That's where it always starts, by the way. Right here on the y-axis. So I have to go left, 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 left. Oh, did mine freeze? Okay, there it is. All right, so I have to go to the left side of that absolute min. And I'm there. Okay, did you make it to the left side of the absolute min?
Yes.
All right, when you do, you hit enter, and it gives you a left boundary. Now, you may not have this dash line right here, but you may. It depends on how new your calculator is. If you got one from the school, you don't have this. I think do you have one? Does it give you the dash line? I think the newer calculators will. Okay, so let's go right now because it's prompting us for a right boundary. And we'll hit enter over here. So now, you can always check to see if you're doing it right. Your arrows should be pointing towards each other. And right in the middle of them should be your min. And then we always hit enter for guess. And now this is our min. feel this. Neat. Snip this and go back to our notes. So this is where our min is. Oops. That absolute min is this y value. So there's actually two ways we can write that. The easiest way is just as an ordered pair. Negative 3.179 and then negative 15.469. And that's our absolute min. Okay? And then we can go back to the calculator and find these two. These two. This one is a relative max. This one is a relative min. Okay, I want everybody to go find that now. And if you're not sure what to do with your calculator, I want you to ask. The other two, please. All right. There is none. So it's only a relative.
Yeah, it might be. Sorry, guys.
So you do, you choose this. And then you come to the left side of that one. And do it. Right, so you can do it.
Do what?
Wait.
Here.
It's here. Yeah, what's like theme? I don't know yet. We don't know.
Is there?
Here, just a second. Back down this.
I tried.
Yeah, the graphs were the ones.
All of the words.
All right. Okay, so let's go ahead and go through the process. I'm going to find this max right here next. So make sure you hit second, trace, and choice 4. That's max. So we go just to where we're on the left side of the max. So I got really close to that peak. And I'm going to hit enter. Then I go over to the right side of the max. And then I hit enter. And I always hit enter for guess. So this point right here is this maximum value. So I'm going to snip that and paste it over here, back in our notes. Oop. Okay. Well, I just want to go right on top of the last one. It's just going to want to do that. All right, so that maximum value is not an absolute max. This is a relative because there are some points above it and there are some points below it. So this relative max is the point negative 0.915 is what that would round to. And then 3.042.
You have to put 3 decimals.
Your teacher may be just fine with 2. Yeah, at least 2 decimal places. And then we'll go back and we'll snag this last one, which is a relative min. This problem has no absolute maxes because it goes up forever. There's no highest point. So we go back to our calculator now, calculate this min. So we'll do second calc. Come on. Choice 3. Go move the cursor to where it's just on the left side of the min. We hit enter. Move the cursor over to the right side of the min. Hit enter. And then you hit enter for guess. And this is our final one. This min is this point here. So I'm going to snip it and move it into our notes. Okay, so this min is the point 0.344, comma, negative 0.803. Got it. So that's everything we need. Now, now we can do all the stuff from yesterday. So we can answer in behavior. We really could have done in behavior even without the graph, but looking at the graph makes it really easy. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches positive infinity. All right, any questions about the end behavior? All right, increasing, decreasing. Yesterday in here, this is what we did. This was our approach. At the bottom of the graph, we would draw an x-axis. We call this our x-axis, and our x-axis goes from negative infinity to positive infinity. On the x-axis, we put the x values at our maxes and our mins. So this first x value is negative 3 point, I'm just going to say 2 because I don't have much room. The next one is negative 0.92 and the last one is 0.34. And then what we did was if we started over here on this side of the graph, we have to go down. So this first interval is decreasing. And then when we get down here, we go back up. So the next interval is increasing. Then we go down, decreasing. And then we go up, increasing. So this one was increasing between here and here, and increasing from here to forever. So it increases from this x value, negative 0.915, to this x value. That was wrong. It increases from negative 3.179 to negative 0.915. Then it increases again from this x value, which is 0.344, to infinity. So those are the two where it has to go up and up. Now we need to do the decreasing. Where did it go? Down and down. So it went down from negative infinity to that negative 3.179. Then it went down again from that negative 0.915 to the 0.344. All right, domain. Nobody's going to miss this because the answer for domain for every polynomial function is that. Every polynomial function has a domain from negative infinity to positive infinity because it keeps going out in both directions, whether it's both up and out or down and out, left and right and out. It goes out in both directions. Range. Range is the lowest y value to the highest y value. Now I'm going to erase some of this stuff. Actually, no, let's just go back and look at our graph over here. All right, so what did we say this y value was down here?
Negative 15.469.
Negative 15.469. Do you guys see that that is the lowest y value on the whole graph? And then it goes up forever? So if we're talking about range, the lowest one is that negative 15.469, and then it goes up forever, so it goes to positive infinity. Yes, sir.
If we didn't have any absolute values, how do we find the range?
Okay, that is a really good question. It is possible that we won't have any absolutes because odd degree functions go up and down, or they might look like this. Odd degree functions, the ends go in opposite ways. So when you have an odd degree, not only is the domain from negative infinity to positive infinity, but the range is too. Because with an odd degree function, one end goes up and the other end goes down. So the only time we'll have a restricted range is when it's an even degree function. And wasn't this an even degree right here? So when we have even degree, your range will be different. When you have odd degree, the domain and range are both negative infinity to positive infinity. Okay, so that gets us to today. Today only adds one thing. Phew! Okay, today we're only adding one thing. So I'm going to sneak this big graph right here. And we'll talk about what we are doing with it today. Today, we're looking at where the function is positive or negative. Okay? And the y values are always positive above the x-axis, and they are negative below the x-axis. So it's positive above and negative below. So if I ask you where this function is positive, it is positive over here because that's where it's above. It is positive from here to here because that's where it's above. And it is positive from there to there. And then where is it negative? It is negative down here, from here to here, and it is negative from here to here. That's where it's negative. So just like with intervals of increase and decrease, we're going to use these x values. Well, this one's pretty easy to see. Negative 1, negative 2, negative 3, negative 4. This x value right here is negative 4. This x value right there is easy to see. That one is 0. Now these two we're going to kind of have to guess, estimate what you would think these are. Well, if this is negative 1 and this is negative 2, what would you estimate this one to be? 1 point what? Okay, I like it. 1.8. All right. What about this one? If this is 0 and this is 1, what would you estimate this one to be? All right, I like it. All right, so this function is positive from negative infinity until we get to this x value, negative 4. Then it jumps because now it goes negative. So now it goes negative from here to here. So it is negative from negative 4 to we estimated this one to be about negative 1.8. See, it goes down below. Now we're going back up above. Up above the x-axis, the y values are positive again. So we got another one where it's positive. So we're going to use a union symbol, which just tells you mathematically that there's more. Both of these go together to give us the positive. So it's from negative 1.8 to this x value, 0. Then it dropped down below. It's negative. So it's negative from 0 to 0.9. And then finally it finishes off and it's positive. So we actually have 3. 1, 2, 3 intervals where it's positive. So that last interval is from 0.9 to infinity. And that's how you determine where a function is positive or negative. Okay, so that's what we would put in these last 2 little blanks down here for positive and negative. All right, so what I want you guys to do is I want you to try number 3 on your own. Okay, this is how you're earning your classwork points today, along with your notes for the first problem. I want you to try number 3 on your own. But as soon as you get stumped, I want you to ask for help. Okay. We're going to end the video here, but that won't end the notes. It'll just end today's video.